in the last geometry class, we have learned all the chapters, right, no children? As I told, geometry is finished. Then also I am doing again the geometry. Means one chapter I told that one it is nothing but a what theorems, right? No, chapter 17, that is nothing but a special types of quadrilaterals, as I told you. So in that lesson, according to the ICSE board, as I told, out of 100% of the syllabus, we have to do the 70%. 30% they have reduced, right, no children? According to that, 70% in that revised syllabus, what they have given means, according to this chapter, they have given only to introduce the theorems for you, depending upon the special types of quadrilaterals. So what I will do means, in this lesson, I am going to teach only the theorems. I never ever do any exercise, children. Exercise is reduced for this year. Only they have given theorems to do it. So what is the theorem? Theorem is nothing but, it is theorem number 2, parallelogram. So in this lesson particularly, theorem number 2, parallelogram is there. Theorem number 3 is also depending upon parallelogram only. Theorem number 4 is also depending upon parallelogram. So what I will do means, only theorem number 2 is enough, children. If you learn theorem number 2, it is including theorem number 3 and 4. They have given the part for theorem number 3 and 4. So no need to do theorem number 3 and 4. So I am going to do the theorem number 2, that is parallelogram. Then I will go to theorem number 5, rectangle. Then I will go to theorem number 6, rhombus. Then I will go to theorem number 7, square. So total you have to learn 5 theorems in this year, children. So I already taught you in the understanding shapes, that is one of the basic theorem, that is quadrilaterals. So you have learned how to derive the theorem and how to prove the theorem by using construction and even the proof, everything, diagram using, based on how you have to prove. I have taught in the last classes, right, no children? So now let's move on to the theorem number 2, that is parallelogram. So before going to the parallelogram, just I'll give introduction about the chapter, children. Special types of quadrilaterals. See, look here, what is meant by special types of quadrilaterals? The name itself it is showing the special types of quadrilaterals. The lesson name, lesson number 17 means chapter 17, special types of quadrilaterals. What is the special? Special means it should be a special, right? No. Surprise means how it will be surprise, like the special means it should be a special. As we know that three-sided figure is nothing but only one and only shape, that is a triangle, right, my children? Quadrilateral, quadri means four-sided figure, right, my children? Four-sided figure. Laterals means sides. Four-sided figure, any figure we can came to know that one, it is a quadrilateral, right? No. So what is there in that special means? Quadrilateral is not a one shape. It is so many shapes are there. That's why it is totally a special types of quadrilaterals. Let us see, children. We know this is one type of shape. Understood? Next one, this is one type of shape. Okay. Next one, this is one type of shape. Okay. Next, this is one type of shape. Correct, my children? See, all are looking like a quadrilaterals. You may ask, ma'am, yes, this is all a four-sided figures. And we have learned in the theorem number 1 like this. Correct, my children? What we learned, it is also one of the quadrilateral we have learned. And another one is there, that is a trapezium, that is like this. So it will be a the shape is like this, children. So now look at here. You may ask, here you see how it will be the shape. All the shapes are in four sides. Then what is the special? See here, three-sided figure means just we will draw only this one. Correct or not? This is a three-sided figure, right? No. We have got this one as a triangle. Is it no? Aditya, are you seeing video or what? Somewhere you will see, means in whatever the time you need at that time you will see, right? No. See here, if you are watching the video at the right time, you will get the things very properly, children. Please watch the video at the right time when we will send. Next, look at here. This one, special types of quadrilaterals. So these are all four-sided figures. figure, four-sided figure. Just we did not have any name for this one. Just it is a quadrilateral because it is having four sides, four angles and two diagonals if you draw it. Then we come to the special types. This is a parallelogram. What is this one? Parallelogram. Why it is a parallelogram? Because it is a special feature, that is both opposite sides are parallel. Opposite sides are parallel and equal. This is the special feature for this one. That's why we are calling special types of quadrilaterals. Each and every quadrilateral is having their own special thing. That's why we are calling this one as a special types of quadrilateral. So what is the special type of quadrilateral? Special thing for parallelogram is opposite sides are parallel and equal. Opposite sides are parallel and equal. Opposite angles are equal. That is called, this is one of the type of quadrilateral, that is parallelogram. Parallelogram speciality is what? Opposite sides are equal and parallel and opposite angles are equal. Come to rectangle. Rectangle we know, correct no children? What is this one? Rectangle is also one of the four-sided figure, right? No. In this four-sided figure, Ayush, you have learned from lower classes, right? No, rectangle, square and everything, right? No. See, Arya, so in rectangle, we are seeing the angles here, that is exactly 90 degree, correct? No. And here, opposite sides are equal. Opposite sides are equal, correct? No. These opposite sides are equal. Rectangle is also one of the parallelogram. Rectangle is also one of the parallelogram. Why? Means opposite sides are equal and parallel. Here also opposite sides are equal and also parallel. It never be intersect anywhere. Understood? This is also one of the parallelogram. Why? Means only one feature is added. That is opposite sides are equal and parallel. But another one speciality should be there, no? Because one is copied from parallelogram. What is another one speciality? Another one speciality is it is exactly at 90 degree. But parallelogram is not there at the exactly at 90 degree. Have you understood, children? So this is called specialities. Each and every creature in the world having their own unique and specialities, right? No, children? Same like that. Even the quadrilaterals is also having the speciality of their own. Understood? So this is one of the parallelograms. Parallelogram speciality is opposite sides are equal and parallel. And opposite angles are equal. Then here the rectangle. This is nothing but rectangle. Rectangle speciality is opposite sides are equal and parallel. Means rectangle is one of the parallelogram. But speciality of rectangle is it is having exact 90 degree. Understood? Next you get know. We know this one. This is square. Correct? No. What is the speciality? All the sides are equal. All the sides are equal and it is exactly at 90 degree. This is the speciality of this quadrilateral. It is nothing but named as square. Why? Means it is all the sides are equal. All the angles are equal and the speciality of the square is all the sides and angles are equal. I hope you have understood, children. Next one you come to rhombus. Rhombus means all the sides are equal. Then what is the speciality of the rhombus? Square and the rhombus is same to same, children. But square, it never changes the angle. Square, it never changes the angle. What it will do square? Square is exactly at the 90 degree. But rhombus is not like that. It changes the angles. You can construct any angle the rhombus. So rhombus, when it is come exactly at 90 degree, it is equal to square. I hope you have understood, children. So it is nothing but rhombus. Rhombus speciality is all the sides are equal and we can construct the angle for any angle. Means we can construct a rhombus for any angle. But this one is not like that, exactly 90 degree. We have learned about the quadrilateral already, right? No. Some of all the angles of a quadrilateral is 360 degree. All these quadrilateral sum is also 360 degree. Have you understood, children? All these sum of the angles of a quadrilateral is also 360 degree. And this one is a trapezium. You don't have this one for this year. Just we have learned trapezium area. Have you remembered? trapezium is nothing but half into a plus b into h. A plus b means what? Opposite. These two lines are parallel. Opposite sides are only parallel. That is called a trapezium. And you may know that one. It is looking like a, here we will get one of the triangle also, even rectangle is also. So these are all the special types of quadrilaterals. I hope you have understood, children. Before going to the theorem number 2, parallelogram, just I told what are the special types of quadrilaterals. So which are the special types of quadrilaterals? Special types of quadrilaterals are, this is we have already learned in the understanding shapes. Quadrilateral basic. Quadrilateral. All these quadrilaterals are having the same feature. That is, some of the angles of a quadrilateral is 360 degree. All the quadrilaterals is 360 degree only. All the quadrilaterals are having 4 sides. All the quadrilaterals are having 4 angles. Understood? This is common thing for all the quadrilaterals. But speciality is there. Parallelogram speciality is opposite sides are equal and parallel. Rectangle speciality is opposite sides and angles are, the opposite sides are equal and parallel. It is exactly parallelogram. But where its speciality is 90 degree. Here, square, it is all the sides are equal. All the angles are equal and it is always be 90 degree. It never changes the angle. That is the speciality of square. Then what is a rhombus? Rhombus means all the sides are equal. You can construct the rhombus for any angle. So that is the speciality. And when it is come exactly 90 degree, it looks like the same feature of the square. Then quadrilateral we have learned, and the trapezium. Trapezium we will learn in the next year, children. So it is an opposite sides are parallel. I hope you have understood, children, about this speciality of all the types of quadrilaterals. Let them move on to the theorem number 2. Theorem number 2 is what, children? Theorem number 2 is nothing but parallelogram. Let them see what is the theorem, how we are going to be learning the theorem. So theorem is what, children? Theorem is theorem. Correct? No? Theorem is theorem. Samvadam is samvadam. Max means max. Theorem is theorem. Theorem means it needs proof. Correct? No? We have to prove the theorem. Let them see, children. See, it has come. Theorem number 2. What is the theorem number 2? Parallelogram. It is depending upon the theorem number 2. I never give. I will tell statement prove. Parallelogram theorem. You should know that one. It is theorem number 2. They have given one of the diagram here, children. Just I will write here. Diagram they have given. This is A. This is B. C. D. Correct, my children? And next one. Both the opposite sides are parallel. Just I write here. Opposite sides are parallel. And they have drawn imaginary line. This is A. This is B. And this one is C. And this one is D. Correct, my children? So this is the diagram they have given in your textbook. Let them see, children, by using this diagram, how we have to prove the theorem. First of all, statement. Theorem means what are the things it should be there. Statement should be there, given should be there. To prove that it should be there, and we have to prove it should be there, and hence proved it will be there. If it is needed, then only we have to draw the construction, children. Let them see, children, how we have to draw. So statement, what they have given the statement? Statement they have given in a parallelogram. This is one of the parallelogram. Speciality of the parallelogram I already thought, that is opposite sides. This one side and this one side are parallel and equal, and this side is parallel and equal. Correct, no, children? So now what is the statement? In a parallelogram, this is a parallelogram, opposite sides are equal. So opposite sides are equal. Opposite angles are equal. This is angle A is equal to angle C, angle B is equal to angle D. Correct? No? Then each diagonal bisects the parallelogram. I have drawn only one diagonal, children. This is the diagonal. Diagonal means opposite vertices it should be connected. This vertices to this nothing but diagonal. I have drawn only one diagonal because if you prove for that one diagonal, it will be similar to another one diagonal. No need to draw another one diagonal because when we prove inside the parallelogram, if you draw one diagonal and if you prove it, means it is similar to another one. So that's why each diagonal bisects the parallelogram. If I draw one diagonal, it will be create how many triangles? Two triangles. Right now, if I draw another one diagonal, two diagonals if I draw, means it will be create four triangles. So enough two triangles, children. So what is the statement? Statement you have to buy up. In a parallelogram, opposite sides are equal, opposite angles are equal, each diagonal bisects the parallelogram. Preetham, you should by heart the statement. Correct? Next we will go on to the given. What they have given? According to the diagram, a parallelogram A, B, C, D. One of the parallelogram A, B, C, D. Next, to prove, what we have to prove? By seeing the statement, we have to prove. Opposite sides are equal. First one, see our first one. AB is equal to DC. Correct. Next one, AD is equal to BC. Same that one I have written. Now, opposite angles are equal. See our second one. Angle A is equal to angle C. Angle B is equal to angle D. Next one, each diagonal bisects the parallelogram. Third one, AC bisects, this is the AC, bisects means dividing the parallelogram, that is, how many triangles are creating? Triangle ABC and is equal to triangle ADC. Correct, no children? I hope you have understood, children. Next, BD bisects. Just I draw here only for your sake, children. If I draw another one, if I draw the line like this. Now look at here. BD bisects the parallelogram. Correct? No, BD bisects the parallelogram. Then what did we create? Triangle ABD is equal to triangle BCD. I hope you have clear now what is statement, what is given and what is to prove. I hope you have understood, children. We have to prove first one, second one and third one. How we have to prove? Let them see, children, how we have to prove. I hope you have understood, children. So first one, opposite sides are equal, opposite angles are equal, each diagonal bisects the parallelogram. Let them move on to the proof. So here construction is nothing but what they have given. Construction is draw diagonal AC. Draw diagonal AC. So what they have drawn? They have drawn the diagonal. Just I draw another one time the parallelogram, children. This side I draw. Look at here, children. This is A, B, C, D. Correct? No? Opposite sides are equal. Opposite angles are equal. Correct? No? Now what we have to do? Draw. This is what imaginary line. As I told, construction. It is nothing but draw diagonal AC. We have drawn the diagonal AC and we have to prove. Now we have to prove that one. What we have to prove? We want angle A is equal to angle B, then angle C. Angle C is equal to angle D. So how we have to prove? Let them see, children. First, before going to the first, second, third to prove, just first we will make the general thing. How we have to prove that tendon. So first we will take triangle ABC. This is triangle ABC and triangle ADC. So when we take two triangles, when we draw an imaginary line, it is going to be creating two triangles. Right now, if you create two triangles, it will be creating the angles. So angle A is dividing into two angles, angle C is dividing into two angles. Correct, children? So angle A is equal to angle B. This is angle A is equal alternate angles, corresponding angles, and adjacent angles, vertically opposite angles, co-interior angles. This is all you have learned. So angle A is equal to angle B, alternate angles. Angle C is equal to angle D, that is also alternate angles. That is also alternate angles. So these two are alternate angles. Then AC is equal to, this line is common for this triangle also and this triangle also. Have you remembered the congruency? Maybe everybody has forgot the congruency. So Mahendra, Manish, have you remembered the congruency? I have taught you 5 congruencies. Correct? No? Yes, yes, yes. SAS, ASA, RHS and AAS. So these are all the 5 congruencies I have taught. Means it should be a similar. Correct, no children? Here 2 angles and 1 side is there. So it is nothing but which congruency? ASA by ASA, because AC is the one of the imaginary line. It is a common base for ABC triangle and ADC triangle. Correct? No? That's why angle A is equal to angle B, angle C is equal to angle D. That are alternate angles. So 2 angles and 1 side. It is nothing but congruent. It is nothing but congruent. So triangle ABC is congruent to triangle ADC. By which congruency? ASA. By keeping these 2 triangles, let them prove one by one. Have you understood? Let them prove one by one. I hope you have understood now. We have made now to prove opposite sides are equal, opposite angles are equal, and opposite each diagonal bisects the parallelogram. How we have to prove? By keeping this one, let them see children. So this is common for all the 3 proofs. Understood? So triangle ABC is congruent to triangle ADC. Now it is ready. How it is ready? Because 2 angles and 1 side is there. We have proved both the triangles are congruent. Means it is similar. Let them start proving one by one children. First one what it is there? First one is that both opposite sides are equal. Correct? No? According to our, see here, first one is that opposite sides are equal. We have to prove this one. AB is equal to DC and AD is equal to BC. Let them see children. How we have to prove? Since, so we have proved, since triangle ABC is congruent to triangle ADC. We have, by keeping that one, we can prove. Once in both the triangles are congruent means opposite sides are equal, opposite angles are equal, otherwise all the sides are equal, all the angles are equal, and the diagonals are equal. Everything it should be equal children, because as I told you, once both the triangles are congruent means we can conclude all the sides are equal and all the angles are equal. I hope you have understood children. Look at here. By since means we have already proved this one. What we have proved is this one we have proved. By keeping this one, I am doing the next one. So next one is what? Triangle ABC congruent triangle ADC. By keeping that one, AB is equal to DC and AD is equal to BC. See, for keeping these two, we have proved this one. What is this one? CPCDC. CPCDC means in your textbook it is there children. Corresponding parts of the congruent triangles are congruent. These two are congruent triangles, right? No. So for that reason, when 2 triangles are congruent, corresponding parts is also congruent. That one only it is telling. Corresponding parts of congruent triangles are congruent. It is nothing but CPCTC. It is there. Full statement it is there in your page number 190. 189 and 190. This theorem is there. If you want, you can write this one full. But in exam and all, you have to write full children this one. Corresponding parts of congruent triangles are congruent. Means once the 2 triangles are congruent means remaining corresponding parts and all should be congruent only. So this one we have proved. Again, since triangle ABC is congruent, again are congruent. Correct? No? By seeing that one, angle B is equal to angle D. Angle A is equal to angle C. Because when both the triangles are congruent, all the corresponding angles are also equal. So that's why these two are opposite angles are equal. Opposite sides are equal. Why means we have proved by congruent triangles. By ASA congruency we have proved both the triangles are congruent. Then since triangle ABC and triangle ADC, this one corresponding triangle ABC is congruent to triangle ADC, both the triangles are equal. Congruency means equal only. Already they are equal. Once again, congruent triangles are equal. Correct, no children? Next, look at here. Diagonal AC bisects parallelogram ABC. This is diagonal AC. Bisects means dividing. Parallelogram. So it is creating what? Two triangles. Same. A, B, C, D. Now look at here. Similarly means same like this parallelogram. Similarly, by drawing the diagonal BD, I have drawn the diagonal, another one diagonal. It can be proved that triangles here ABD and triangle BCD are equal. Means both the two are also equal. Correct, no children? If one diagonal only we have proved both the triangles are equal, means another diagonal if you draw also, both the triangles are going to be equal. See here, so similarly by drawing BD is one of the diagonal. How AC is one of the diagonal, BD is also one of the diagonal. If you draw this diagonal, how many triangles are creating? Two. Which are that? ABD, BCD. See here, triangle ABD is equal to triangle BCD. That is BD bisects the parallelogram ABCD. So AC bisects also we have proved. Similarly BD if you write this, that is also going to be proved as a parallelogram ABCD. Hence proved means we have proved this one. If you want you can write it this one here children. Otherwise no need. I hope you have understood children. So whatever the things are we have learned from the theorem. From starting I am telling this one. See here. Just I am showing here theorem number 2 parallelogram. It is there in your textbook 189 and 190. By seeing this video also you can write the theorem. Otherwise you can see the reader also you can write the theorem. Theorem should be written both in running notes and CW. It is compulsory because it should be practiced mandatory. Understood? See here statement. First you have to write the statement, then given to prove. Then you have go on to the construction. By using the construction, you can prove the triangles are congruent by ASA. By keeping these two triangles, we are proving one by one. Opposite sides are equal, opposite angles are equal, and AC bisects the parallelogram. That is, congruent triangles are equal. When AC one diagonal if you draw, both the triangles are equal means another one diagonal if you draw also, almost all both the triangles are equal only. So totally AC and BD both the bisects the parallelogram ABCD, and all the opposite sides are equal and opposite angles are equal. Then each diagonal bisects the parallelogram. Each diagonal. This is one diagonal and this is one diagonal bisects the parallelogram. I hope you have understood children. Hence proved. This is very important children. After the theorem you have to write this one. Hence proved. I hope you have understood the theorem. So you have to practice this theorem in your running notes and CW properly children. And theorem number 1 also you practice. Theorem number 1 is nothing but quadrilateral theorem. Theorem number 2 is parallelogram theorem. Let them move on to the next session. Theorem number 5. 3 and 4 is no need children, because whatever the theorem number 3 and 4 it is there in this theorem itself. So that's why no need to learn about theorem number 3 and 4. Let them see theorem number 5. Theorem number